Hi, welcome to another video tutorial for the Linux class. On behalf of Vector Consultant, my name is Cecile, and in today's video we will be covering the topics we see on our screen. inode, file systems, and if time permits, we're going to look at one major topic, also. So let's begin right away in order to save time. So in Linux, what's an inode? Okay, an inode, say, is an identification number for each file system and directory in the Linux system. So that means each directory or file system we create, there is a number that is automatically created alongside the process of creating the file or directory. So that number alone identifies that file or directory, and it also carries all information about the file. So let's write that down. Say inode is an identification number for each file and directory. Okay, identification number for each file and directory. For each file and directory in the Linux system. We also say it carries all the information of the file the directory. So what we're saying is, for example, after creating a file, if we go back and modify something in the file, the inode information also changes. Okay, let's look at that practically in our server. I'm going to bring on my Linux server right here. This is my Linux server. I'm already signed into it. So where am I right now? I'm on root. Okay, and let's do a little inventory. Let's to see what we have right here. So in the root directory, I see a couple of files and directories, but I don't know which one is a file, which is a directory. So I'm going to do my ls-shell to long list and to give me more information. So it gives me, long list and give me the attributes each file and directory, so that this way I can tell which is a directory in the D and this is a file. So I'm going to use this test file for our example on inode. Okay, that's the file, test file right there. So if I ls test file, it gives me back test file. Okay, so to really using anything in the file. So for inode, we see when we explain we can modify something in the file, the inode information also changes, right? And there are two commands used for inode. Okay, so and those commands are command start bracket with display inode. Okay, example, I could say start then file name. So start then the name of the file will give you the inode information about that file. Same thing for directory. Okay, ls-il file name. This will also display inode information and a lot more actually. So Okay, so these are the two commands I know we will be working with. So back in my server, I'm going to create a file. Alright, I'm going to create a file, and then we use that file to exercise the inode we are talking about. But before I do that, I'm going to create a directory, move into the directory for us to do this example. Okay, I don't want to do it in the root directory, though it really doesn't matter. But so I'm going to create a directory. I hope you remember our command to create a directory, mkdir. I'm going to call this direct. Okay, so direct directory that we created. I'm going to cd direct. Yeah, am I right now? I'm in direct. Okay, direct directory. So in this directory, I'm going to touch a file, and I'm going to call it file1. So I've created a file. That's it. I just added the directory. There's a file they call file1, and in file1, so let's do our inode. So start file1. So and it gives us bring my mouse. If we look carefully, the file is called file1. The size is 0. The blocks is 0. Blocks are just, like building blocks that make up the file. Just like you build a house, you put the blocks together and makes up the house. Where is it written? Here it's written the inode number. That's the identification number for this file. Okay, so it's written the inode 131108. Now, if I go back and modify, we just written regular empty file. Okay, if I go back and modify this file, say for example, I add content into the file, the size is going to change. It's no more going to be regular empty file. You see, we see something here, the UID, the GID. We're going to see that when we're going to user and security management. That's when the file was accessed, modified, date changes that were made, the date and time for all of that. So when you go back and modify a file, all of those updates, will be reflected right here. So I know it's a good tool, to verify changes that have been done in the file, especially in a work environment. Many people working on the file, and you was like the lead or supervisor in your group, other team members. You can always go back and see if some modifications have been done in the file and everybody's doing their job. So let's write on. So let's say I go back into the file called file1, and I'm going to put content into it. Okay, so let's say echo I love Linux, and I close my quotes and redirect it into file1 that is in file1 right now, right? So I could do my start again, run the file1, and hit enter on my keyboard. Guess what? I hope you see the changes. Right now the file size is 13. Before it was 0. Now it is 13 because there's content information in the file. The blocks was 0. Now the block is 8. You see, as you keep updating, adding stuff in the file, the block number keeps changing. Okay. It now shows regular file. It's not an empty file anymore like before. Now it says regular file. Okay. Modification, date time. Say if it was done a different day, it will reflect right here. Okay. So, and the inode number doesn't change. It's a identification number for that file. But the block number changes, the size changes, so that's how you know the file is growing, getting bigger and heavier, and occupy more space in your system, more storage space. So that is that for inode. Let's look at the other command. So let's say do ls-il file1 plus what. So it gives me the same inode number. The inode number comes first, and the rest of the attributes that make up the file. Okay, so that's that for the inode command. Practice it and get to know it. Next on our topics is file systems. Okay, file systems. Should I put the examples on the notes? Probably not. You're gonna have the video, so I don't think I need to. I know the examples we did in the server on the notes. Anyway, let's proceed. So the second topic, that's pretty for iNodes, which is why I said probably we will look at another major topic. So file system, Linux file system. Okay. So about file system, if you remember in one of our early classes, I drew a table or a diagram where, you know, it's spread out. I spoke about an inverted root tree where I drew a slash, we root a file root, and then I spread out left and right with other directories, you know, like the home directory, the, you know, various directories that I drew, and I said as a tree structure, like converted tree structure of order in which files are organized in the server. We spoke about that. So that's the order in which files, you know, rather directory keeps saying files. Anyway, you're right, files, because they're in directories set up. So file system, you know, that's what file system is about. The file system is more like the organization, the positioning of data in your storage, you know, device, say in your hard drive, you know, and the file system is a layer under the operating system that handles the positioning of data in your storage device. Without that, the system cannot know which file, you know, starts, where the file starts and where it ends. You know, the Linux file system, you know, unifies all physical hard drives and positions into a single directory structure. You know, it's a directory structure. So I remember what the table was trying to talk about was the directory structure. You know, it all starts at the top with the root directory, and then all of the directories and the subdirectories, you know, spread out from there. But that's basically what a file system is, you know. So again, file system generally is a layer which is under the operating system that handles the positioning of your data in the storage or on the storage. Without it, the system cannot know which file starts and where it ends. Okay, so that's what the file system is. So again, I could define another way. File system is the way in which files are named, you know, they are stored, retrieved, as well as updated on the storage disk or partition in your system. The way files are organized on the disk, you know, all of that is all about file system. So we're going to look at some file systems in Linux. Okay, first one, root fs, which means I'm going to use the curly brackets. Root fs, which is the file system. Alright, root fs for root file system. It contains operating system components. It runs the, this runs the Unix operating system. It's about Unix. So contains, I'll just say OS, it's operating system. Operating system, oops, components. It runs the Unix operating system. This runs the Unix. This is Unix general Unix operating system. Okay. So I'm going to give you file system for Linux as well as file system for Unix or Solaris, which is another flavor of Unix operating system. We spoke about it in the first class, if you remember, at the library. Second file system, it's good to have knowledge of all. Second file system, UFS, which means, I shouldn't put it in uppercase. UFS means Unix file system. Okay, this is the default file system for the Solaris operating system. Even though we're not dealing with Solaris, but it's good to have knowledge about it. So I'm giving you, it's default, I guess the default FS, Unix file system for Solaris. Solaris 10. We have to expand the backup. Solaris 10 and older versions of Solaris. So that's what this. Third one is ZFS. Okay, ZFS means zettabyte file system. Alright, also used as a volume set. So this is also default. Okay. It's also a default file system for Solaris. Okay, this one is Solaris 11. Okay, the other one was Solaris 10. This one is Solaris 11. A different version on the Solaris operating system. And this is also used as a volume manager. We will look at volume management. That's a topic we have to just learn. One of our feature classes, volume management. So, but as ZFS is used as a volume manager in Solaris. Write that down here. The fourth one, okay, this is where we focus. EXT, I think I mentioned this in one of our previous classes. EXT, which stands for what? Extended file system. Extended FS. And I'm writing full. Extended file system. And this is a default file system for Linux. Okay. Linux, both CentOS and Red Hat versions of Linux. Linux 6. Okay. ext, it's in the file system. For Linux 6. Keep in mind Linux includes both CentOS. Just going to put that in bracket. CentOS and Red Hat Enterprise Linux 6. So examples of G. So you have examples of ext files. So say you have ext1, ext2, ext3, okay, ext4. Right, so that for file system for Linux. Let's keep going. The fifth one, TMPFS. Okay, TMPFS temp file system. Temp file system. And sixth one is swapfs. Okay, so swap file system. We're going to look at swap management. That's another big major topic we will discuss or learn. Swap management. So temp file system and swap file system are both to work together. Okay, so I'm just going to give the note below, this line, because they work together. So they work together. Okay, to run application and run applications. Run applications on the operating system. Okay, and they are also needed during application and operating system installation. Okay. Also needed during application operating system installation. The next one is process file system. Process file system rating like this: proc fs. It says process file system. This one manages all system processes. That's just it. Okay, manages all system processes. That's what proc fs does. The next one is NFS, network file system. Okay, actually there are a few that we work with all the time, like the ext, the swap, and NFS sometimes. So NFS, which means network file system. So the NFS, network file system, multi-platform file system. Okay, used to share files, share directories in Linux and Unix operating systems. So NFS works in both Solaris and Linux. So that's why they call it a multi-platform file system. I'm just going to write that down and say it's a multi-platform platform. Platform. Let's put that first. You understand this file system used for sharing directories. Okay. And directories in Linux and Unix operating systems. Okay. And XFS is one around called XFS, the code file system for Red Hat 7, CentOS 7. I just put that down, just take note of it. It's XFS. Which is what? Put it this way. Default for Red Hat plus Linux 7 and CentOS 7. Okay. The next file system we need to know is MNTFS. MNTFS stands for Mount File System. Okay, this one manages all file system mount points. We look at mount points when we're working with logical avoidance. Okay, swap management. That's a mount point. Real quick, a mount point is like when we create a file or write a directory. We do is set up a logical volume. We'll make it to mount on that newly created directory. That directory that we are setting, to newly created directory. That's what we call a mount point. Going to mount on that directory. Okay, which means if you do a logical volume and you don't create a mount point, it won't be seen when the server is starting and running. So the user cannot mount to it, they cannot access it. Anyway, you may not understand that, but we'll get deeper when we are dealing with logical volume and the rest. Okay, let's write on 11 is HSFS. Okay, interesting. This is high Sierra file system. Okay, high Sierra, like Sierra, high Sierra file system. Alright, it's used to mount. Okay, let me write it down. Used to mount ISO images, CD, and DVDs. Okay, media. Okay, so ISO image, when you mount the CD, instead of CD into a Linux file and it runs, when it's running, it's because the ISO file system is installed in the system, in the server rather. Alright. The last one we're going to look at is DevFS. Okay, which stands for Device File System. Device File System. This one manages all system devices. Okay, e.g. hardware. Okay, that is hardware rather, each. System devices, it's like hardware devices. So then I would say get to know dev fs, get to know mount fs, get to know NFS. We're going to study NFS as a topic on its own. Get to know swap, get to know exe, extended file system. Those are the ones we'll be looking at subsequently. File systems. I'm going to look at, so now next we're going to look at the device files in dev fs. So it contains two major directories and a file. Okay, the device file system, you're going to see first that contains two major directories and a file. So two major directories and a file is /dev directory. That is /dev directory. This one, it contains the logical names of system devices, and the logical name of the device is the label given to that device by the operating system. Okay, for example, what that means is, okay, let me go on my server. For example, we do ifconfig. So it is ETH1 or ETH0 in your server. That's the label given to your NIC. Okay, and that NIC card in the system, it's a device, it's a hard device. Okay, so that label, the name given to it, this NIC, it's what we call a logical name. Okay, so that's /dev directory, contain the logical name of the system devices. So that ETH0 you see is stored in /dev directory. Okay, the other one, second directory, is /devices. So /device directory contains physical names of system devices. The first one contains logical names, while this one contains physical names of system devices. So the physical name is the OS description of a hardware device driver. So I said that again, the physical name is the operating system's description of a hardware device. So when it's also a description of that hardware device, the description of it is saved in the /devices directory, right? That's the difference between these two directories. And the single file that we say the dev fs contains is what called etc instance file. Let me write that down. So we have /etc path _2 _ instance file of the file. So this file contains instance name of the system devices. So what I'm saying, the instance name is the kernel's abbreviation of a physical name. So the kernel, called the operating system, the physical name that we have in the /devices directory, physical name that are stored here, they have abbreviations which are in this file. In this file called etc part to instance. Okay, that's where they are. So I hope that explains these two directories and a single file, that are in the dev.fs file system. So make it easy, just say a logical name which we saw in the /dev directory is a link to a physical name in the /devices directory. You see the point? So dev.fs, we have /dev directory, which is equals to logical name, and devices directory is equals to physical names, and it's a part of instant file is equals to instance names. Okay, and this is what kernel abbreviation. And then y physical name is driver description. And this one is OS level. So that's like a summary of what I just explained. So again, I'm going to take that again if you didn't get it. So we say the dev.fs or device file system, right, manages all system devices. That is hardware. Okay, all the system hardware are managed by the dev.fs. Okay, and it contains two major directories and a file. These are the two directories. The first one is /dev and /devices. This slash is like root, then dev, then root, then devices. And the file is, this is the file right here, part to instance. Part to instance is it's inside the etc directory. Okay, that's what. So that's it. So we see this first one, /dev directory, is a directory that contains logical names of system devices. That's why. So that is equal to logical names of system devices. Okay, and those logical names of a device is the label given to that device by the operating system, so OS label. And we gave an example. We said like the ETH0, ETH1, depending on your server 9, this is what has a logical name. Okay, because that's the label given to the NIC card, which the NIC card is a hardware in your system, in your computer. Right, well now open the machine, but the NIC card, yeah, it's a hardware in your computer that enables internet connection, for the system to have network internet connection, right? And that's able to obtain an IP address and all these IP information, networking information, right? So that NIC card has been given, and the operating system has given it a name, ETH0, right? And that name is what we call the logical name, and is stored in the /dev directory, right? And the second one is the /devices directory, which we say it contains physical names of system devices. Okay, so the system devices, now each device in the system has this real, like, this name, so they are stored in this directory. Okay, and what did we say? We said the physical name is the operating system's description of a hardware device driver. Now every hardware in the system has what we call drivers that are stored in the operating system, that are stored in the hard drive that are linked to the operating system. So the drivers are like particular software that enables the hardware to work with the operating system in the computer. Put Linux aside, take your regular Windows computer. There's certain hardware that when you link them up to your computer, or for example, you can install a Bluetooth mouse or a certain mouse, or there are some flash drives that when you connect them to the computer, before it loads, it will first tell you device drivers installed. So you have to install those drivers for that hardware now to read, for the operating system to read it, and then you can now see it on your screen and work with it. So the device drivers are stored in the /devices directory for Linux. Okay. And then the last one, this file called path to instance. Okay, we say it contains instant names of the system devices. And say the instance name is the kernel's abbreviation of a physical name. Okay, so that physical name of that device whose this driver is installed, that name will be abbreviated and it will be stored in this file. And the kernel is the one that creates the abbreviation. Kernel, the Linux kernel. So I hope that explains the /dev file system. If you have any further questions, we could discuss that later in class. I'm going to end here for this video, and stay tuned to the next video that will begin a new topic. Hope you learned something